Hello. Ah, there we go. Awesome. So, is there anyone who's not speaking German? Perfect. Okay, so we're gonna do it in English. Not that I had planned any other thing, but just for the sake. Okay, so don't go Java, or don't go Java? Huh? Well, whatever. For maybe some people like or already know this like session. For that reason, I thought, well, maybe from time to time you should actually update it. So I updated the slide deck. That's the 2019 edition. It doesn't mean it changed anything else. It's still the same kind of weird stuff, but well, at least we have an updated slide deck. We unfortunately only have 40 minutes, so I have to rush a little bit. But if there's something completely unclear, believe me, it's because of Go, not because of can't explain that, right? Okay, so disclaimer. Every good presentation needs a disclaimer. You know the Oracle presentations, like everything I talk about, don't trust me, don't believe me. For me, the disclaimer is, well, I kind of like Go. I'm sorry. Yes, it doesn't mean it's good. Okay, so to begin with, we're playing a little game. Guess the movie. Who knows what movie that is? That's not enough people yet. Now? A few more? Now? Yeah, a few more hands, and yes, exactly, Caddyshack. Who knows that movie? Oh, now everyone's like, yeah, sure, I know that. So Caddyshack was a good movie about a gopher. I think he was the hero of the story. I'm not 100% sure if that is like the way it was supposed to be, but that's how it played out. Today, the gopher will probably not like the hero, right? But before we go on, people probably saw this picture already. That is me in a very peculiar situation, wearing a tie. So we're just ignoring all of that. And here's how I see myself, right? So I'm the master builder, obviously. I mean, every one of us is. So there's a couple of programming languages I really like. And yes, TypeScript is one of those. Don't blame me. As I said, I kind of like Go. It still is not a good language because it has some weird shit going on. There's some stuff that I'm sometimes forced to use, and I really don't enjoy it, especially Python. For people that wonder, there's three bad Ps. It's PHP, Python, and Perl. Okay, see, we're all on the same page. And we're in Germany. Most of us are Germans. What do Germans do? We love beer, obviously, right? So that's my most important thing. That's the reason why I put it on the end. Okay, Go. What is Go? Who worked with Go so far? Who likes Go? Who thinks Go is a fantastic syntax? Nobody. Okay. Why are you here? Why are you here? Okay. So you guys probably know the JavaScript, the good parts. I started writing Go, the good parts. It's opinionated. I'm done. So. Right? Cool. Actually, I like opinionated things, and you might understand I'm opinionated going through the session. So what Go actually is, it's a general purpose language. It was created somewhere around 2009. That's at least when Google open sourced it for the first time. We're around 1.12.1. That's the current release. The interesting thing about Go is they're really hard trying to not break backward compatibility. So as Java developers, we actually like that. Don't we? We do, right? Okay. So, but they still add new stuff. That's a really interesting thing on how to evolve the language, because the language features itself make it possible to evolve that way. Okay, but we're here to laugh about Go, right? We're here to learn why it is so shit. No? Who's laughing? Why? Oh, I don't think it's meaningful. Okay, so we're having a little bit of source code here, and over time there's like a little bit of hints to understand the syntax. You already figured out nobody had this hands raised up when I said is Go a good syntax, so I have this like feeling I have to explain how it works, right? So here's type inference. Type inference is a big thing in Java since Java 8, right? We know that. So here's a package declaration. I think everyone got that, right? That's close enough to Java. You have a main entry function, no class, no public static void main. It's actually much better than Java in this case, and it's probably the only thing. You have a variable declaration, and there's a colon equals. That means you're creating a new variable and you're assigning a value at the same time. any Pascal or Delphi people around? Right? Why would you do that, right? Okay, a variable itself and, well, as I said, the instantiation and the string. What is the type of value? String, obviously. Okay, good. You're still awake. That's good. Okay, the problem is that actually does one thing. It does not compile. Cool, right? And why does it not compile? Wow, because we have an unused variable. You can't do that in Go. Nope. The Go compiler tells you, you know, no unused variables in my compile domain. Not gonna happen. Okay, so you would have to use it to make it actually compile, or you would remove that. That's amazing for hacking something together and for testing things out when you comment something in and you have now an unused variable, like, oh, shit. Okay, so I do some more comments and I'm trying to figure out how to do that, right? Okay, but who cares, right? For release, that's actually a pretty good thing. We don't want that. So next thing, and a pretty extensive standard library. And being Java developers, we like that because that's what Java gives us, a very extensive standard library. And you see there's I/O, and IOUtil gives you a lot of functions like, hey, read everything from this file and return it as a string or a byte array, something like that. Pretty cool stuff. We have our package declaration or package import declaration here. And when I'm talking about extensive standard library, I really mean extensive. So pretty much everything from the Java world we have. Not everything is nice. I just recently had to use the SQL interface, and believe me, it's horrible. That's just what you have to believe me right now. But going back to our example here, the import statement, and what do you think? Obviously, it does not compile. Same reason, just different idea. Now we have an unused import, same thing. It's like, yeah, nah, nope, nope, nope. Go compiler, it's like, no. Computer says no. Not gonna happen. Apart from that, there's a couple of very interesting things here, right? So in Go you have, oh, sorry. Yeah, well, we can go for that. So you can have actually multiple return values. And you see there's a lot of parentheses already. There will be more in the future. No worries. Go loves parentheses. So that means you're returning a tuple named x and y, and both values are type int. That's actually a pretty nice thing, and I would love to have that in Java. Who returned an array just because he wanted to return 2 ints from a function before, right? That would be like awesome. You see, there's still a lot of stuff where it could say, yeah, I like that. So that's actually kind of nice. And when you assign it, you're just like doing a deconstruction pretty much of the tuple. Okay. Automatic resource management. As I said, I'm really sorry. We have to speed up a little bit. So there's a couple of weird things here. One of those is we actually ignore one of the return values with the underscore, like in Scala and stuff. Like, no, we don't care. We see what that is in like a minute. So the first one is the file reference, and the second one is whatever right now. And we have a defer file close, and that's actually a pretty cool thing. Looking at Java with the automatic resource management, or try with resource, that's like, yeah, it's all right. That's a nice approach. It's not perfect. What the defer does is to tell the Go runtime, whenever you leave the method, please execute this method. So we do something, and when we leave the main method, the Go runtime will make sure to actually close the file for us. That's pretty neat. No try finally blocks, whatever. So that's actually nice. But then there is a few things which are like, now it really becomes awkward. Error handling. And you see there's this OS open again. And this time we're not ignoring the second return value. It's an error. An error can be of any type as long as it has an error method, returning a string. So that means you can do weird things like having a Boolean type being an error as long as you tell false as a string method. So it's like, yeah, okay. But the really bad thing here is that whenever something returns an error, you actually have to check. If the returned error is non-nil, please return the error further down the stack. And that's one of the things where it's like, yeah, if you write a microservice, two files, 3 methods down, no big stack, that's all right. But when you start to do something more fancy, you're actually handing down the error down the stack and down the stack and down the stack. As a Java developer, we would expect that at least we got a stack trace from this position where we actually started, right? That's what we do in Java. Exceptions get a stack trace the second they were created. In Go, they unfortunately don't, right? So there is something that is called panic, and when I panic something, I get a stack trace from exactly that position. That means if I had handed down an error like 20 levels, I have no idea what this actually happened. It's like really bad design. It feels so C level, and I mean, we're like C, right? I forget something here. What was? Oh, right, yeah. If I hand it down, obviously I have to return nil if it all worked out, right? Because it's a return value. It's a type. Well, yeah. Anyway. Public versus package private. Public versus private, that's what what Go calls it. I would say it's package private because it's okay as long as it's in the same directory. Who knows how Go handles public versus private? Just shout it. Capital and lowercase. Very good. So, what do you think is public and which one is private? I'll make it easy. The uppercase one is public. So uppercase first letter makes it public, lowercase letter makes it private. Unfortunately, I think Ray is not in the room anymore. Maybe we have somebody else being able to speak any of the Asian foreign languages. What do you think is that? I'll give you a hint, it's Japanese. What do you think? Is that public? Is it private? It's Japanese, that's true. It's actually private, and that's a big issue. Because the Japanese character set doesn't know uppercase letters. So Go in Japanese, hopefully nobody does that, but if they would do that, it would not actually work, because everything would be packaged private, or you put everything into a single package. Obviously that works. Right? That's how we do good applications these days. From a syntax perspective itself, and I said we get a couple of more parentheses just for the sake, just because parentheses are so awesome and they are so different each time. We now have another set in the first, or before the actual method name. So in Go, you have to understand there's no objects, right? It's not an object-oriented language, it's a struct-oriented language. But you can add methods. You can pretty much inject methods afterwards to a struct instance or to a type instance. That means we're actually creating a receiver type method or a receiver method. So what it means is in Java, the f would be this. Now f is our this instance, the one that we're actually calling this method on. And the other thing is just a pointer to the type foo. Yes, pointer arithmetic. Yes, pointers. So we actually bind it to the type pointer to foo, which is different from foo. For people that are coming from the C area, you know the difference. But because it's so awkward to have only like 3 sets of parameters, and I know that somebody asked me before if Go these days already have generics. Does Go have generics? Wrong. It does. It does. The map is actually a generic type. It's the only type in Go that actually has generics, because the Go team was like, no, when your types need generics, that's bad design. Oh, by the way, we need to add a mat type. Yeah. We have that in Java. We have things which are possible from the JVM, but not possible from a language perspective. Ever thought about array length, which is a read-only property? Something that doesn't exist in the language, but the JVM can do that. They can do it as well, just for the sake. But as I said, 3 lines or 3 pairs of parentheses are not enough. So Go thought, okay, maybe we were wrong about generics. Maybe we should add them. How would you add a generic to make it obvious to people that it is a generic? You add another set of parentheses, right? So now you have a generic type of pointer foo, which has a generic of, what is pointer string? Now imagine you have pointer foo of pointer foo of pointer foo of pointer. You get that, right? The number of parentheses would probably bring everything, including Emacs, to its limitations. Anyway, I could go on forever, and that's not even the worst stuff, right? So right now I already feel like that, but we're getting to the good things, and I have like 25 minutes left. That's like almost impossible to do. Where are we gonna get there? So 5 things I really hate about Go, but you don't have to. Okay, so you remember we had a little bit of Caddyshack, so it's coming back right now. And I tried to find a picture which kind of explains what is going on. So you're a little bit crazy, right? Okay, so we have something, and ignore the second pairs of bracket. That's just to make another what's called region or scope. So we're just making sure that var is in a different var1 is in a different scope from var1. But if we call the foo method and pass in foo, we override the var1 in another scope. So what does it print? It prints bar. I think that's close enough for everyone to understand, right? You shadow, and that's the actual term. You shadow the variable var1, and you get a different value. Okay, that's not too bad. We have that in Java. In JavaScript, you could probably do some more funky stuff, but yeah, okay. That was actually double. So now we're getting a little bit deeper, because it's not only going to work for variables, for all the non-obvious reasons, right? I mentioned JavaScript. They can do it, so why wouldn't Go do that? So we now have a struct type, which is called task, and just for the sake, that's actually an instantiation of a pointer variable, so we're instantiating a new instance of a task, a pointer to task, and we're trying to do the same thing one line further down just for fun, right? So what happens? Well, the Go compiler will tell you that on the second instantiation, there is now a type error, because you can't create a new instance of this instance you created before. So the task variable actually shadows the type, which doesn't make sense. Every meaningful compiler should be able to figure that out. Those are two completely different things. What is the solution in Go to fix that? Well, they're falling back to this like C behavior. Your variable should be called T. Sure, why not, right? Then you have T1, T2, T3. Anyone ever looked into some bigger C code base? That's what it looks like. Oh, by the way, there's some good Java code to do that as well. If you ever look into the fork join pool, you figure that Doug Lee is an amazing C programmer, because that's what his Java code looks like as well. So yeah, so that is an actual problem, right? And you're like, okay, but we can go even further. One more important notice here is, imagine you have this not line by line, but like 10 lines out, right? Or some colleague actually adds another instantiation on top and doesn't think about he's probably overriding a type that you created, right? And it's just stupid for the compiler to not make this distinction except for you using JavaScript. JavaScript, everything is a function, so obviously type is a function too. Anyway, okay, cloning. And that's one of my favorite topics, because it took me quite a while to understand how this works. So that looks a little bit more complicated, but believe me, it's mostly only reflective stuff. So there's not a lot of stuff going on. If you use Java reflection, you're close to understand what's going on afterwards. So that's actually returns the reflective type, the type at runtime of this variable, which is called, what is it, val? Oh, I was so impressively creative. Val. So that actually is a switch case. It's a pattern matching. It says, well, if your runtime type is an integer, please say I'm an int. If your runtime type is a handle, please return I'm a handle. And in the top, you see type handle int. So for people coming from other languages, C and a couple of other things, you would understand, okay, now I created an alias for the type int, which is called handle, something which is very common in the C world, for example, right? Unfortunately, somebody at Go, or at the Go team, thought that's a stupid idea. We don't want alias. We want a type clone. So you get a new type which behaves exactly like int, but is completely distinct from it. So that means if you actually call this with two different variables, var1 and var2, it will actually work. It will say one time it will say I'm an int, and one time it will say I'm a handle. Sounds legit, right? So far, you're like, yep. I think that actually is pretty legit. The interesting thing is, did anyone realize I switched the slide and something changed here? Nope. I'll make it again, just a little bit more obvious. So we had that, right? Type handle int, and now we have type handle equals int. So now we actually get a type alias. And that's like an impressively visible difference for everyone looking at the source code, right? And a type alias is actually what it sounds like. When I can actually call this now again, and it will behave exactly the same way. Actually, it will not even compile anymore, because now handle and int is the same type, right? So yeah, it will actually go into both cases. It doesn't make any sense anymore. But why am I talking about that? I mean, that's like a weird thing. Why would I do that? Well, the thing is functions. Functions are first-class citizens in Go. And a function is, or a type callable, for example, is just an empty function, doesn't take any parameters, doesn't return anything, right? Just an empty func that you can actually call and you're good to go. By the way, yeah, it's func. Func is, right, we have everything. Fun, func, function in JavaScript, Java thinks we don't need anything. Yeah, I'm not sure if they thought it's funky to call it func. But we're actually calling it from my callable, and we create a new closure, which is func println, and it will actually just print on the console callable. And then we execute it. So we pass in a callable, and that's good. The interesting thing happens when you try to be a little bit more reflective. And when you're writing frameworks and stuff, everyone actually looked into reflection in Java at some point. Who used reflection before? Right, there you go. That's what we do in Java. So now we changed our test function a little bit, and you remember that's a type, that's the runtime type, and we're having no equal sign. So what we get is two distinct types, depending on if we pass in callable 2 or callable 1. One is defined, so callable 1 is a closure, which is defined by just creating it. And the other one, we say, hey, we have a new variable, which is callable 2, and that is specifically of type callable. So please do that for me. And then we assign the function. So the Go compiler knows, OK, that is supposed to be a callable, so it will be a separate type, right? You remember? Two distinct types. One is only the empty function, the other one is the empty function we call callable. And your runtime type now behaves differently, because only the first thing will actually execute, because our reflective test does not include the callable anymore. And that is like, you're looking at your code, you're writing it, everything feels right, and at some point you're like, why doesn't it work? Why does it only work for like half of the callables? And look at the types, and they look exactly the same, and it doesn't make sense to you. And then you figure out, oh, they're actually distinct types. How can we fix that? Well, we just add the equals, right? We're saying our type callable is actually an empty function. No parameter, no return value. And that's how you fix it. And I was like, yeah, sure. And that only works since Java, I think, 1.9 or something. Anyway. So, looking a little bit crazy. And this one is probably a little bit more complicated. So let's see. And in case you found the last one complicated, believe me, that's a little bit more. So we have a couple of things here, just to make sure. That's a map instantiation. I said map is reflective. So we have, sorry, that's actually not a map. That's an array. I'm sorry. It's a slice, a list, an array, whatever they call it. I think they're 100% sure themselves. So that should be an array instantiation. We have a loop that actually loops 3 times. And every time in a loop, we create a new closure, capturing the value of I, and actually storing it in the array, and afterwards we just execute it. That's fairly simple stuff, right? We do that in Java all the time. So if we execute those 3 functions now, what would be the outcome of that? What would be on the console? Obviously, it says iterate a value 3 times, but what is the value of I in this case? What is the latest? Free, exactly, will always be free. What would we expect from Java? 0, 1, 2? Probably, right? Why? Because Java captures the actual value of I at that point in time. We're creating a closure, and a closure keeps the state of this point in time. What happens in Go, I is not actually captured as a value, it's captured as a pointer. And the pointer is free after your last test, because that's your break condition for the for loop, right? So I is free at this point in time. And it's like, with values like integers, it's probably like very obvious. You're just executing, you're like, yeah, okay, I get that. It's still weird, but I get that. But if you're doing it in a for each loop over objects, and you're getting an object you don't even expect, or you get nil and you have no idea why, because in your array there is no object at that point anymore, that's like a really weird state. And I was looking at that, I was like, I think I found a runtime bug. That can't be right. I mean, even with Go, that can't be right. And I went into the Gopher Slack and posted this code, and I was like, what is the outcome? And in seconds, we were like, free, free, free. I was like, what? What do you mean, free, free, free? Yeah, that's how it works. And they posted a link to the FAQ, like, why is that happening? I was like, what the fuck? Am I stupid, or is like the rest of the world? Like, wow. So they also gave me a hint on how to fix that. So you're just creating an intermediate function, which takes a parameter of type int. The I actually shadows the I around that, but we don't care for that. And that returns another function, our closure. And you execute the first function. You see that for people that use JavaScript, you know this like function call of an immediately generated function, and you pass in I, which now becomes the parameter, and at that point in time, it actually becomes caught by or captured by the closure. That's easy, right? I'm like, no. So there must be a better way, and somebody found a better way. Oh, you can actually shadow the variable. You can just create a new variable with the same name, and you assign the value, and that actually does the same thing. It's not better. Believe me, it's just not better. And I mean, if you write this code and you look at it tomorrow, it's like, yeah, okay, I get what I did. Look at it next week, and I'm like, what the f? Give it to a colleague and say, understand that. And he's like, what did I do to you? Why are you so mean? Right? Okay. But we're not done yet. So aren't we all a little bit gopher? For the Germans between us, we understand where this is coming from, right? So interfaces. Interfaces are an amazing thing in Go. So interfaces are inherently implemented. So as long as a type has every method that is defined in an interface, you have implemented this interface. Go is not the only language doing this kind of crap, but they also thought it's a good idea. So who thinks that's a brilliant idea? Oh, there's two people? Wow, what does the rest think? Why is it bad? Did you ever have like a bigger source code base where it had like two interfaces being exactly the same name but have a different contract? Right? Like a string method. If you have an interface like toString, what does that do? Does that return a pure string? Does it return, well, JSON? Does it return, well, we all heard the best thing in the world, XML. We heard it this morning in the community keynote. You just don't know, right? Because you might have three different interfaces that look from a method signature look exactly the same, but they have different contracts. But that's not even the worst thing, right? So you can create a struct. And you remember, structs are just types. So I have a new type, and I use this receiver method definition again. And I say, okay, my struct now has a method sort, which is another, which actually gets another sortable, and that actually implements the interface. All right. So now my code base is evolving a little bit, and I'm going to extend this interface because I figure I missed something. Now I want to make sure that I'm not actually compiling it over and over and over again every time finding another spot in the source code, which is still broken, but I want to know it immediately at one point in time, this type is not implementing my interface anymore. In Java, we have that because if the second you put an implement something into the source, the compiler will scream at you and like, no, that is not going to work anymore. If you use IntelliJ, it's going to scream at you, nope, that's going to work anymore. If you use NetBeans, maybe too. I don't know. Well, forget about that. So the Go people were like, yeah, we have a solution for that, right? So they were like, yeah, you can actually do this. And you remember I said there's a difference between the no pointers type. So the asterisk mystruct would be a pointer type, and that's a non-pointer type. So to make sure that both types, or both type variations actually implement your interface, there's like this amazing idea of you just create two variables, but you actually don't give them a name, and you're trying to cast that. And actually, you can cast nil to that. We all understand null was a great idea, right? Was it like the $2 million, 20 million, 200 million? I don't remember what the number was, but it was more than I earned. So it was a bad idea. And they're like, yeah. So that's how you actually test your type for being compliant to an interface. Who likes that? Who thinks that's a great idea? Who can remember that tomorrow, right? Every time I use that, I have to look it up in my own slide deck, like, how the shit did this happen? Or did this work, right? I'm like, okay. But there's one better thing, and that's like the craziest thing of all. And you see, it's nil or nothing. So who believes that nil or nothing should actually to be two different things? No JavaScript people? Well, okay, that's good. In JavaScript, it would be null and undefined. That's nil or nothing. In Go, it's actually, well, there's only nil, but nil can be different. So you remember I said an arrow type can actually be everything as long as you have an arrow methods, right? So that's the arrow interface. By the way, one more important thing. Who realizes something about this interface name? It should be private. It's not. It's not. It's insane, man. No, I'm sorry. Why the hell, right? It's lowercase. It should be private. It's not. It's like there's no generics except for map, right? So no. But as long as we have this arrow method, everything is good. Okay. So we're going back to our interface. Okay. So we have a test method. You realize I love test methods when I write Go code because every time there's something weird happening. So now we create a variable of pointer to my arrow, and we say it's nil, right? So we assign the value nil. And we have a parameter which is v. And when v is true, we return specifically nil. And when it's false, we return this pointer to my arrow, which is also nil. So our test, obviously, on the bottom, should be true, right? In both cases, we return nil. Yep, sure. I heard that. So who thinks that's actually what's happening? When I ask that way, nope. And you're right. If I ask that way, it's obviously not going to work. So here is, from my perspective, the worst thing that can happen to a language. So the interesting thing is how interfaces work in Go. So interfaces are a combination of the type of the interface and the actual value that backs this type. So for us, this pointer to my arrow, which is returned as an arrow, right? So our return value from the test function is an arrow. So we're actually casting our type my arrow to the arrow interface. And that says, well, so the arrow has a type which is pointer to my type, and it has a value which is nil. The problem is the Go specification says only if both values are nil, you actually have a nil value on an interface. So that means some weird idea of how you actually implement something in the language comes up to all the way bubbled up to the user and kicks you in your fucking ass. Like, no, it's not going to work, right? So as I said, type and value. Type is pointer to my arrow, value is nil. What happens if we return nil specifically? Well, we cast nil to an arrow interface. In this case, both is nil. So actually, those two things behave completely different from a language perspective. And that's something which is built in the language. So that means even if they figure something like that out, they can't fix it anymore because now it became a defined behavior of the runtime. And it's obviously wrong. I think we all agree on that, right? If I have a variable which is assigned or which has a value of nil and I return that, I expect the return value to be nil. If anyone thinks otherwise, please go back to JavaScript. No, just kidding. But it's like the worst thing that can happen. And that's one of the things I really like about Java, that we have a slow progress, right? New features are not coming up like every other second, like in other languages, but they're normally like really well thought out. And I know JPMS, and yes, sometimes they're not. But normally features are pretty well thought out, or they implement it in a way that they probably can change it afterwards if they have like not the perfect idea yet. One of the amazing features of Lambda, or one of the amazing feature of Lambda in Java is how they're implemented. They are implemented as a recipe which the runtime which the JVM at runtime spins up from the recipe, like the actual implementation. So that means if they figure out a better way to do this in like 4 or 5 years, they can say, that's no problem. We only have recipes, so whenever the new version comes around and we have to implement the recipe, we use the new way, right? So you have a backward compatible way, and things like that don't happen anymore. So, and I'm really good in time, so we have 5 minutes left just to blame a little bit more on this stuff. And always remember, I actually like Go, and you can be really productive if you know all of those things. So that's the actual FAQ. And it has, the title or the subtitle for this section is, seriously, I don't give a fuck. And that's what it should be, right? I shouldn't read through all of that. And there is, by the way, where is it? I don't remember. Somewhere in there is this error problem we just talked about before. And I think for every one of the stuff or things in the slide, there is actually an explanation on the FAQ. Who believes it's a good idea to have to document behavior in an FAQ to make sure that people actually understand what you intended? Oh, there's one person. That was a trick question. You should have said no. Right, but I mean, that's a really weird thing somehow. When I have to define something or describe something in a way that I expect people to show up, and I mean, an FAQ is meant to be read like from everyone, right? It's a frequently asked question. If something like that ends up in the frequently asked questions, I'd say that's probably a wrong way to implement it. I don't know, maybe I'm different from anyone else, and I still don't see like my amazing, I don't remember. It was somewhere with the error. It's actually, why is my type not what I expect it is? It's like really weird stuff. And for this thing where I said I posted it on the Gopher Slack, I actually got another answer, not only like 333 and the link to the FAQ, I also got the answer like, yeah, everyone in his Go life has to come across that. I was like, okay, sure, why not? Maybe they were just stoned when they came up with some of those things. Maybe they didn't think about it. Maybe they were drunk. I mean, we all know this. For people that were in the keynote, yes, we were kind of drunk yesterday when we actually created all this stuff. We deployed it 5 minutes ago, and yeah, right? You don't really do that. Anyway, that's like the final step. Remember, I'm not here to scare you. Go can be... First one's like, no. Or you didn't do that. Nope. No, seriously, I'm not here to scare you. Go has a really good purpose when you build one thing, and that's like very small microservices. And a lot of them. You can be amazingly productive in Go for microservice applications. I actually, for another startup I'm working with, we created a server application which serves just a couple of REST endpoints on different subdomains using Let's Encrypt, which is part, or the Let's Encrypt client is actually part of the standard library for the HTTPS in Go. And all of the, okay, I have a new subdomain. I don't know how to handle that yet. I go to the Let's Encrypt client, I request a new certificate for that, I configure the certificate, and I serve it with 15 lines of code. who can tell you, I can do this with 15 lines of code, right? So you can be productive in Go. It's just you have a lot of pitfalls which are like really weird sometimes. So yes, don't be scared. There will be dragons, but if you read the FAQ, everything's good.